Alright, so the problem says relate two objects that start at x equals 0, at t equals 0, and move in one dimension independently of one another. Graphs of the velocity of each object versus time are shown below. So we got these two different velocity versus time graphs, and we got these three questions that we want to answer. The first one, which we'll answer, which object is farthest from the origin at t equals 2 seconds? So we need to be able to look at these graphs and determine which one is further from the starting point. So if we look at the first one over here, it has a starting velocity of 1 meter per second. And this is -1 down here, +1, -1. This is time of 1 second, time 1 second, time 2 seconds, time 2 seconds. Okay, so when you look at these graphs, the first one, we will call this object A, and this one over here, we'll call this object B. So object A starts at 1 meter per second. That's what's going on right here. And then it suddenly transfers to -1 meter per second at this point right here. So for the first second, it goes in the positive direction for at 1 meter per second for 1 second. And then it goes backwards at 1 meter per second negative, or 1 meter per second backwards for the second. So object A is actually back where it started, if you look at this graph. And then object B, it starts off at 0 meters per second, but it ends at 1 meter per second. Now, it didn't get there immediately at that 1 meter per second. It slowly sped up to 1 meter per second. So the first one, it started at 0 and it moved forward at 1 meter per second, and then it went backwards at 1 meter per second. Now, another little trick that you can do with these graphs is you could take the area underneath the curve. So let me erase some of these lines here. What I mean by the area underneath the curve is you take this section of the graph right here, and the area underneath the curve on a velocity versus time graph tells you the displacement. Now, if it's area above the line, that's positive displacement. If it's area below the line, that's negative displacement. So if we take these two areas right here, those two areas are going to cancel each other out, which means it's basically back to the starting point. But we can take the area underneath the curve of this line over here and notice that it's all positive displacement. So that's another sign to say that object B is furthest from the origin. Now let's look at number 2. Which object moves with a constant non-zero acceleration? So what it's saying is, which one of these is moving at a constant acceleration that's not 0? So basically we're trying to figure out which one of these two is speeding up. Now, if you know much about velocity versus time graphs, say this is a velocity versus time graph, any sort of slope shows a acceleration. Okay, so if it's a positive slope, negative slope, whatever. But the slope has to be constant for the acceleration to be constant. Now, technically, this is a slope right here. It's a flat slope, but that slope is a slope of 0. So that shows 0 acceleration. And this question doesn't want to know about 0 acceleration. It specifically says it, non-zero acceleration. Now, we also need constant acceleration. So it needs to be constant and it needs to be non-zero. So we know, looking at object A here, there is no acceleration unless you're counting 0 as your acceleration, and we're not. So if we look at object B here, we notice that the car is speeding up, but that slope, you notice this slope line is not staying steady. It's actually curving upwards. So this curved line on object B shows that there is an acceleration, but that acceleration is not constant. The slope is getting steeper and steeper and steeper as you go. So if we want a constant and a non-zero acceleration, well, the answer is neither of these have a constant non-zero acceleration. It would have to look like this for it to be a constant non-zero acceleration, a steady slope, not a curved slope and not a flat line. Now let's look at the third question. Which object is at its initial position at time 2 seconds? Okay, so this is another one of those where we're just going to read the area underneath the curve. And when you read the area underneath the curve, you see that this area and this area, as I said earlier, they canceled each other out. So that means that this has a displacement of 0 for object A. Object B, it's all positive displacement. So that shows that it's not at the origin anymore. It's not at its starting point. And object A, it is, because it went forward at 1 meter per second for 1 second. That's this part right here. And then it went backwards again, -1 meter per second for 1 second. So it just basically went forwards and then backwards again. So for the answer to 3, the answer is object A is back at its initial position.